Okay. Which questions did we want to see you go over on the shark bite? The ones I've seen the most of are 4 and 5 and 3. So we'll do those 3. Even though we're not using iPads right now, you could still use Desmos on your computer. So I will still show you how you could do some of these in Desmos. So for number 3, you could type in the expression using capital X's. And then add the slider, and then change the value to be -3. And it will show you what that would equal. You could also put -3 into the expression using parentheses. Either way, you would get 3. So if you did use one of these methods on your answer sheet, you can just put I did in Desmos. Stop. Questions on that one? Okay. For number 4, you could also do that one in Desmos. If I were to put both ordered pairs in, I can see that these fall on the same line. So as I'm looking for my slope, my rise is 0, but I have a run. So it would be 0 over some number, which would still be just 0. Number 5, you don't need Desmos, but you can use it. I'm going to show you what your graph would look like, and then show you how you could double check yourself in Desmos. So if you started at the point -2, 4, and then use your slope to go up 2 to the left 3, down 2 to the right 3, as many times as possible, your line will look something like this. A little perfect. You don't need to know what your y-intercept is exactly. If you were trying to do that in Desmos, you would put in your y equals mx plus b. Add in all the sliders. Change the slope to -2/3. And then put in your point -2, 4. Thank you. And then you can move your B until it goes through that code by either hitting play or moving this. But as we could see on the graph, it was going to be a decimal regardless. Questions on that one? So go ahead and look at your notes. write that part down. Compound inequalities are two inequalities or more, but we're just going to be dealing with two, that are joined together with the words and or the word or. Or inequalities have a tendency to graph apart, and I'm going to explain what that means in a moment. Have this example, x is less than or equal to -2, or x is greater than 3. That would be like some answer that you would get at the end. You're going to graph both of those on the same number line, how we just did for just regular ones. So closed at -2, going to the left, and open at 3, going to the right. So you're going to graph them both on the same number line. And when they graph apart, they'll look like they're going to the opposite ends. Now, I will say on Delta Math, most of them will look like this, where they're graphed apart. But on Delta Math, you may also be looking at, some of them may not do that, and they may graph on top of each other. But when you read the notation or whatever, the final answer, you're looking at it from left to right. Completely on Delta Math, so keep that in mind. If you need help when you guys work on that, let me know. But the interval notation for that, you're reading it left to right. So this would start at where? If it keeps going to the left. Negative infinity. So parentheses, negative infinity to what point? -2 is closed, so bracket. Then you're going to write the word or. Then pick up again where it starts again at 3, but it's open, so parentheses. And then it ends again at infinity. So most of your or inequality interval notations will look like this. Questions on how to graph or write so far before we get to the solving piece? Okay. So then when we solve or inequalities, you'll have two of them, and you're just going to solve both like normal, but what you do to one, you don't do to the other. They're two separate inequalities. So for this first one, we would do what? Add 4 to both sides. And then for the other one, divide everything by 2. You need to write the word or in between your two inequalities, even if they're on two different levels. Or like you finish one down here and you finish this one up here, write or, put arrows in between them or something, or rewrite it. This has to have or in between it. And then you can graph those two. So starting at -3, that would be open, going to the left. And then at 6, closed, going to the right. How would we write that interval notation? Parenthesis or bracket? Parenthesis. Or what's the rest of that? with a bracket to infinity. So if you only have half of that, you're missing half of the answer. Yes?
Why does infinity have
Infinities always have parentheses. That depends on their open or closed circles. Other questions there? We're going to skip 2, go on to 3. So let's solve this by doing what?
subtracting 9?
We have 2x is greater than 8. Divide both sides by 2. And then on the other side, subtract 10. Keep going. Divide both sides by 5. So that x is less than 0. Make sure you have your or in between them. And then go ahead and graph those. So those should both be open. Whoa, how did we do that? It doesn't matter if you rearrange this, put this so that the less than is on the left and the greater than is on the right. If that helps you see it better, you can do that, but you don't have to. And when we write that interval notation, what would that look like? Negative infinity is where we start. To what point? To 0, parenthesis or bracket. Or starting at 4, parenthesis or bracket. And to infinity. So everything there would be parentheses. It depends on the circles, whether they're open or closed or not. Questions on that one?
Does it matter the order?
For this?
Yeah.
Yes, it has to be read left to right. So least to greatest. So if I'm looking at this, this starts way at in the least amount, and then it goes to the next highest, and then it goes to the next highest, and then it keeps going to the highest. Okay, let's skip 4 and do 5. With this first one, we could either distribute or divide both sides by -3. Which one would we rather? Okay. If you did divide, you would have to change the sign right away instead of later. We have -6x minus 3 is less than -15. Get rid of 3 by adding. And divide both sides by -6. The sign is changing, and this number becomes positive. And then for the other one, how would we solve that one? Not +1, but bless you. Thank you. Subtract 1 to the other side. And then divide by -1. So that x is now less than or equal to -4. And then graph those. We have x is greater than 2, that's open to the right, and x is less than or equal to -4, closed to the left. That interval notation starts at -infinity, goes to -4. Would that be parenthesis or bracket? Bracket. And then or 2 would be parenthesis or bracket. Do we have any questions on how to solve the OR inequalities? Flip it over to the back. So now we're going to turn with the AND inequalities. And everything we just did is going to be opposite for AND. So instead of graphing them together and solving them, instead of graphing them apart and solving them separately, you're going to do everything together. So these have a tendency to graph together. So when you do this, if I have these two, x is greater than or equal to -6 and x is less than or equal to 1, if I plot both of those and graph them, I have at -6 going to the right is closed, and at 1 also closed going to the left. And you see that these lines overlap. The overlapping piece, that's what you actually need. So whether you have all 3 lines or just the part where they overlap, you need at least just the part where they overlap. If you have the other 2, that's fine. But you don't need those 2. Then when we write the interval notation, we don't look at everything. We just look at where do they overlap from this point to this point. So starting at -6, bracket, ending at 1, bracket. Questions on any of that before we keep going? Then what you'll also see is because the AND inequality falls between 2 endpoints, they're written in a more condensed form. So I'm going to take these 2 and write it here. X is greater than or equal to -6, and x is less than or equal to 1. When you write it in a more condensed form, you take the lowest number. You're always going to use less than or less than or equal to signs. Put x in the middle, and then put the highest number on the end. So your answer should always look like this for me in class. In Delta Math, it may not be that way. So for me, your AND inequalities will look like this. But sometimes you may see them separately. I'll show you how to separate them so you can solve them separately if you choose afterwards. When you see this, you're trying to get x in the middle by itself, so get rid of the 4. But when you do that, you're going to subtract it to everything. The most common mistake you're going to see is that it gets added or subtracted to one side but not the other, and then it throws off the whole, throws everything else off. So when it's in this format, it's already in a condensed form, and then you can just graph those points. Starting at -2 would be closed, ending at 5, and you would draw a line between them. But if you still want to see where they overlap, you can still do that, and I'll show you that here in just a second. So looking at just the answer, if I covered up half of this, I could do x is less than 5. Starting at 5, keep going to the left. And then if I cover up the other half, I'd have to read this backwards. X is greater than or equal to -2. Close, going to the right. Then I can see where those overlap. Again, showing the arrows is not necessary. Do that if you want to. If you wanted to change this so it's 2 separate inequalities, just get rid of half for the end. So I can have the first part, 2 is less than or equal to x plus 4, and then solve that. And then take the other side and do x plus 4 is less than 9 and solve that. Now, if you separate it, that's fine, but your answer has to be condensed, regardless. So you would always have less than or equal to signs, put the smallest number first and the bigger number at last. What would that interval notation look like?
Bracket, -2, (5) parentheses.
So sometimes you'll have a mix, sometimes they'll both be parentheses, both brackets, it depends. Questions on that one?
So it's like where it says rewriting and inequalities. When we wrote it after the arrow, that's how you'll see it on the problems, and then that's how we answer it down there.
So on Dust Math, it may just want inequality notation, which would be this. But if it says interval notation, then you want it as this. It depends on what wording they use.
Okay.
But for me, you should be putting it in interval notation and inequalities. You should be doing both. Other questions? Let's do number 8. Again, we're trying to get x by itself, so we can get rid of 4 by adding it to everything. We have -12 is less than or equal to 3x, which is less than or equal to 6. And then divide everything by 3. I'm going to make up an example really quickly. If we had a -3x instead, when we were to divide, all the signs would change. So this would become 4 is greater than or equal to x, which is greater than or equal to -2. But we want our and inequalities less than and least to greatest. So we take this whole thing and flip it, moving the -2 to the left, changing all your signs to less than or equal to, and then moving the 4. So you would rewrite the whole thing if you got something like that. It's not the case here. I just know that. I'm going to stop drawing the other arrows. You can continue to draw that if you so choose. What would that interval notation be?
Bracket, -4. 2 bracket.
Questions on this? We're going to do one more and then we're going to switch gears. Let's do number 10. So number 10, we can either distribute the 2 or we can divide everything by 2. But this only works because everything is divisible by 2. Which would we rather? Okay. We have -2 is less than 2x minus 12, which is less than or equal to 4. Get rid of the 12. We have 10 is less than 2x, which is less than or equal to 16. And divide everything by 2. Go ahead and graph that. And what would that interval notation be?
Parentheses 5. 8 bracket.
How do we feel overall about compound inequalities? Good, okay, not good. We're going to take it up a notch now. If you want to take a second and stretch, stand up, wiggle out any tiredness, you can do that for a second. So now we're going to use our compound inequalities with absolute value inequalities. So we have to remember our absolute value rules and everything we did. They're combined. So if we have a greater than or equal to, what we do once this is isolated, we drop the absolute value and we keep one of the cases the same. If you recall back to our absolute value equations, we make a positive and negative case because absolute value measures distance, so it can go in both ways. So whatever the case is, that would be your positive case. Then you're going to take the symbol and flip the direction and make the number negative. And then you're going to graph both of those.
Wait, why both?
So if we were solving equations, we would have a solution that would have two because of the negative and the positive. Same thing here. So as we graph this, we see that these are graphed apart, which means greater than or equal to are OR inequalities. And even if you don't remember that, as long as you can see what it would look like and use the correct interval notation, then you're good. So then, to write that interval notation, what would that look like?
Negative.
Keep going.
4, 5, in parentheses.
Not parentheses, but bracket. 2 infinity. So what's nice about these is because of the symbol, because you're dealing with the same case basically twice, they'll either both be brackets or both be parentheses for the numbers wise, not for the parentheses, not for the infinities. Okay. Then for less than or equal to, these are going to be ands. But I would do the same thing. Keep this the same, drop the absolute value, keep the sign the same, keep the number the same. And then write it again, but change the direction of the sign and make it negative. Now, you could graph it as is. 8 that would be less than, negative 8 greater than. And then show where they overlap. Or you could rewrite this so that it's in its condensed form. Negative 8 is less than or equal to x, which is less than or equal to 8. Pick the lowest, make the signs less than, put x in the middle for the highest, and just graph this piece. You have options, but you have to do one of them. You do have to get this eventually. And then the interval notation would be
negative 8.
Hold on.
Will you take points off our test for that quiz if we don't put it in the test form?
Yes. Yes.
So I put plus minus in.
No. If we were doing set notation, yes, but we're not doing that. We're doing interval notation and inequality notation. Okay. Other questions on this before we get into some actual solving? Okay. Write this down. Absolute value inequalities are really compound inequalities where less than or equal to is and greater than or equal to is or. To solve our absolute value inequalities, very similarly to how we would solve absolute value equations, Isolate the absolute value expression, make sure the bars, there's nothing outside of the bars. Once that's done, drop the absolute value, create your two cases, keep one the same, and then the switch the sign, the direction of the sign, and switch the number to be a negative. Solve both inequalities, and then graph the solution, write your answer in interval notation. So let's try these examples. After we do, we're not going to do 1 and 2 because those are like what we just did. But we'll try 3 and 4, and then I'll let you guys pick some on the next page. I will say you could, if you wanted to, figure out which type of inequality this is going to be by looking at it if it's isolated. If it's not isolated, worry about that afterwards. So like for number 3, the absolute value bars are isolated. There's nothing outside of there. So since this is a greater than, I know that's going to be an or. So I could be keeping that in mind. Everything is going to be an or. I'm going to graph them separately. I'm going to solve them separately. So I would drop the absolute value and keep one case the same. And then change the sign, the direction of the sign, and the number to a negative. And then solve both. We have x is greater than 5, or x is less than, sorry, that should be 7, and then negative 5. Because it's an or, you still need your or when you write your inequality answers. But then we could graph them. X is less than negative 5 would be open to the left. X is greater than 7 would be open to the right. How would we write that interval notation? How would we write that?
Parentheses, and you comma negative parentheses, or parentheses 7, comma infinity.
Thank you. Questions on how we solve that one? Let's try the next one. So by looking at this, the absolute value bars are isolated. So I can say that nothing is going to change my sign. So this is a less than or equal to, so it's going to be an and. So I could go ahead and drop my absolute value. It's going to be x plus 2 is less than or equal to 7. And the other one would be x plus 2 is greater than or equal to negative 7. Now, if you wanted to solve them separately, in this case because it's an and, that's fine. If you also wanted to condense it, you could do that by just rewriting it. The smallest number first, less than or equal to, x plus 2, would also be less than or equal to 7. Or you could wait wait and do it at the end. It doesn't matter. So I'll show you that both ways will work. Because this would give us x is greater than or equal to -9. This would give us x is less than or equal to 5. And you would rewrite that. Or if you did it this way, if you subtracted 2, you would get the same distance. So it's up to you how you really want to do that. And then graph that. -9 to 5. How would we write that interval notation?
Brackets, -9, 5 bracket.
Questions on that problem? Look at the back. Find any questions you guys want to see me go over or have something about. 8. Any others? 10. And I think that's good enough. So starting with 8, right now it looks like this is going to be an and, but when I get rid of this -2, that might change. So to get rid of this -2, we would do what? Multiply on both sides. And the sign is going to change here. Keep this in absolute value. Change the sign. Now we have a -12. Positive 12. I didn't put my negative. And now it's greater than or equal to, so now it's an or. So we can drop the absolute value and create our 2 cases. So 4x minus 8 is greater than or equal to 12, and 4x minus 8 is less than or equal to -12. And then solve both of those. Have gotten x is greater than or equal to 5, or x is less than or equal to -1, or if you switch those two, that's fine. And then graph them. And how would we write that interval notation? Missing something. 4. Okay. Questions on that one? Let's do 9. So right now now this looks like it's going to be an or, but let's isolate it first to make sure. Get rid of 3 by adding. And then get rid of 10 by dividing. The sign didn't change, so this is still an or. So then you can set up your 2 cases. X minus 4 is greater than 5, and x minus 4 is less than negative 5. So then our 2 inequalities should be x is greater than 9 and or x is less than negative 1. Just make another mark or none. Those should both be open, so negative infinity to negative 1 parenthesis or 9 to infinity. Everything in parentheses. Questions on that one? What would be our first step in number 10? We have 1/2 times 4x, the absolute value of 4x minus 4 is less than or equal to 4. And then to get rid of the 1/2. So instead of dividing, we could do what? Multiply by 2. So we should, at this point, just be multiplying by reciprocals. The sign did not change, so it's still less than or equal to, which means this is and. So then when we set up our 2 cases, I'm just going to write it in condensed form. If you want to write the 2 and then put it in condensed, you can do that. So I have negative 8 is less than or equal to 4x minus 4, which is less than or equal to 8. And then solve that one. Add 4. As soon as we finish this. And then divide everything by 4. So then graph it, starting at negative 1, ending at 3. And that would be parenthesis negative 1 to 3 bracket. Do you have any questions about that one? How do we feel about absolute value inequalities? Good, okay, not good. So, for this, you'll need to practice. If you felt good about the compound, if you just practice this, you'll get the hang of it. It'll get better. So, for the rest of class, you guys can be working on these following things. If you haven't finished the delta math on the multi-step inequalities or the linear inequality word problems, those are both due tomorrow. Then the compound and absolute value inequalities from what we just did is due next week. You can be working on any of those. If you have not finished or started working on the SOL A1 from the SOL packet, you can be working on that. Remember, that is due Monday. You guys can use your computers for delta math or Desmos. Work together. I'll be walking around. If you have any questions, use this time wisely.